All right, let's just dive right in. What if I told you that you could build a powerful, real-time WebSocket server using, well, nothing but pure native PHP? I mean, we're talking zero libraries, zero dependencies, just the language you already know and use. Today, we're going to tear that exact system down piece by piece and show you just how much power is hiding right under the hood of PHP. So what problem are we actually trying to solve here? The whole goal is to make a web page feel, well, alive. Just look at this chat. Alice types something, she hits send, and boom! Instantly Bob sees the message. There's no page refresh, no annoying lag, no awkward waiting. It's just a fluid, seamless conversation. That's the magic we're chasing. And WebSockets, they're the engine that makes it all happen. You know, the best way to get your head around WebSockets is with a really simple analogy. Think of it like a phone call. Once you've connected, that line just stays open. You and your friend can talk and listen at the same time, back and forth, without ever having to hang up and redial for every single sentence. It's that constant two-way channel that makes it absolutely perfect for the kind of fast-paced communication a live chat needs. Okay, so how does this whole thing actually work? It's not just one giant monolithic script. Oh no. It's more like a carefully choreographed dance between a few key parts. So let's pull back the curtain and take a look at the blueprint. Let's follow a single message on its journey from one browser all the way over to another.
Now, what's really fascinating here is the path a message takes. You might think Alice sends her message directly through the WebSocket, right? But she doesn't. She actually sends it as a totally normal HTTP API request. That request hits a controller, which then passes it to a service layer to get saved in the database. And here, this is the really clever part. The service then sends a tiny little UDP packet, basically a wake-up nudge, to our WebSocket server. The server, which has just been patiently listening, instantly springs to life, grabs that new message from the database, and broadcasts it out to every single person connected, including Bob. It's just a really elegant, decoupled setup.
All right, let's zoom in on the engine room, the WSServer.php file itself. This is a standalone PHP script, and it's running 24/7 from the command line. This is where all the real-time heavy lifting gets done. And the secret to its power? It's not some complicated framework or a heavy external library. It's a single, incredibly powerful function that's been part of PHP all along, stream select. This thing is basically the magic wand for asynchronous I/O in native PHP. It lets our server juggle hundreds, maybe even thousands of connections at the same time without ever getting blocked or stuck waiting on one of them. The moment a client has something to say, Stream Select tells our script, hey, pay attention to this one right now. But before that open phone line can be established, both sides have to do this special ritual, the handshake. It all kicks off with the client's challenge. Your browser sends what looks like a normal HTTP request, but it's got this special header tucked inside. sec-WebSocket key. This is basically the browser's secret password, a way of saying, hey, I'd like to upgrade this boring conversation into a full-blown WebSocket. And here's the server's brilliant reply. Our PHP script takes that key from the browser, mixes it with a special magic string, which is just a constant defined by the WebSocket protocol, and uses native PHP functions like SHA1 and base64 encode to cook up the perfect response. By sending back this correctly calculated sec-WebSocket-accept header, the server proves it's the real deal. It genuinely speaks WebSocket. And just like that, the handshake is complete. The connection is officially upgraded from plain old HTTP to a live two-way data stream. Okay, let's talk about one of the most elegant tricks in this entire system, that UDP wake-up call. So the server needs to know the exact moment a new message hits the database. Now, the brute force way to do this would be to just hammer the database over and over every second, asking, anything new yet? How about now? Which is incredibly wasteful. Instead, this system does something so much smarter. The service sends a tiny, one-way fire-and-forget UDP packet straight to the server. And our server's main loop, the one powered by that same stream select function, isn't just listening for users. It's also listening for this special UDP signal. The second that little packet arrives, the server knows, okay, it's time to go to work. It checks the database only when it has to. And what's the result? You get instant message delivery when things are busy, and a server that's practically asleep, using almost zero resources when things are quiet. It's just a brilliant piece of optimization. So that's the back-end engine. But what about the user's experience? What's happening on the front lines? Well, that's where WS Manager JS steps in. It's the client-side hero that tames all the complexity of the WebSocket connection for us.
You can think of WS Manager.js as mission control right inside your browser. It doesn't just open the connection, it pilots it through any turbulence. If your Wi-Fi drops for a second, it doesn't just give up. It automatically tries to reconnect. And it's smart about it, waiting a little longer after each failed attempt. It manages all your channel subscriptions, it processes incoming data, and it wraps the whole thing in a clean, simple API for the developer. It's really the brain that makes the client side both super tough and super easy to work with.
And now for a feature that is, frankly, a total game changer. How do you control a PHP script that's running as a background process 24/7? The old way, right, is to SSH into the server and fiddle with the command line. This system gives you a much better way, a secure web API that puts full operational control right at your fingertips, and you can access it from anywhere. And this isn't just a simple on-off switch, it's really precise control. A soft stop is the polite approach. It creates a little lock file, which the server sees as a gentle request to take a break. The server then gracefully disconnects everyone and just waits patiently. A hard stop, on the other hand, is the emergency break. It finds the server's process ID and just terminates it. No questions asked. It's the difference between saying, please pause when you have a moment, and yanking the plug out of the wall. This whole suite of commands gives you a complete operational toolkit. You can gracefully stop the server for maintenance and then start it up again to resume. You can hard stop a server that's gone a little rogue, and you can hard start a completely fresh process from scratch. The truly amazing part is that this entire toolkit is available through simple API calls. It's full administrative power, and you never have to touch an SSH terminal. So when you step back and look at the whole picture, what's the big takeaway here? I think it comes down to one word: self-sufficiency. A scalable server, a resilient client manager, a full admin API, every single piece of this robust, real-time system was built with zero external libraries. It's just an incredible testament to what's possible when you really master the core tools of the language you're using every day. So there you have it. We've just deconstructed the entire engine of a pure PHP real-time system, how it listens, how it communicates, and how it's controlled. We've popped the hood and seen all the moving parts. And now the only question left is for you. Knowing what you know now, what are you going to build with it?